Yeah. Good evening, children. Good evening, online students.
Good evening, ma'am.
Good evening, ma'am.
Yeah, good evening. I've shared my screen. Visible, right?
Yes, ma'am.
Yeah. Please answer the questions. Yes, children. Get started. So Raja, what is the radius of the cone? 12 meters. Radius of the cylinder? Dileepan, height of the cone? 5 meters. Height of the cylinder? 11 meters. Very good. Madhumita, what's the slant height of the cone? 13 meters. Very good. And Raghavi, what's the expression in words to find the area of canvas required? Will canvas be used to make the floor of the tent? Will canvas be used to make the floor of the tent? No, it can be. Yes, I'll simply ask again because sometimes when I'm confused. Yeah. Huh? No. When you put up a tent, we don't use canvas on the floor. The floor will be the bare ground itself. If you want, you will put a chair and sit, or you'll sit on the ground, or you'll maybe spread a mat or a carpet. We will not cut the material, the canvas material or the tarpaulin material in circular shape and put it on the floor. That will not do. You might have seen tents. They just put up on the ground. Material used to make the tent is used to make only the body of the tent, not the floor of the tent. Only if it is given, you should take. If it is given that the material is used to cover the floor of the tent, then you should add. If nothing is mentioned, it is not used. All right? Yeah. So tell me the expression in words, Raghavi, to find the CSE of the cylinder plus the CSE of the cone. Very good. And Ritika, what's the formula to find the CSE of the cylinder? 2 pi r h. And Navya, for CSE of cone? Pi r L. What's the formula to find? What's the relationship between L, H, and R, Arjun? L, H, and R. Root of h square plus r square. Very good. How do you convert 1 meter is equal to how many decimeters? 1 meter is how many decimeter? 10 decimeter. I'll let you know. Completed. I'll ask you further questions. Anyone has finished? Area is 1320 meters square. Perfect. Yes. Two lakhs. 2 lakhs 24. No, this is 22 lakhs 44,000. I think what I have. I have 2244,000. So how do I read it? 22 lakhs 44,000. Yes, correct. We haven't online students. We haven't discussed the answer in full. I'm just sharing with those who have completed here in the class. Please complete it. We'll see the answer in detail. Yeah, time to see the answer to question number 1. Yeah. It's blurred, children, but can you read it? The second row, children. Is it? Okay. Yeah, so please check. I think radius, height, and slant height, all of us found. Area of canvas required is equal to CSA of the cylinder plus the CSA of the cone. 2 pi RH plus pi RL. You can work them separately and add, or you can take out common like this. Pi R is common, 2H plus L. Yeah, and while substituting the value for H, you should be careful. H is H of the cylinder, not H of the cone. Where we can go wrong is 2 pi RH is here. H is the H of the cylinder, not H of the cone. H of the cylinder is 11 and L of the cone is 13. So I have taken pi R common. So in bracket 2H plus L. So pi is 22/7 into R, radius 12. I've substituted, and then that amounts to 1320 meter square. 1320 meter square. But I think the cost is given per decimeter square, right? The cost is given 850 rupees per 50 decimeter square. Correct? 850 rupees per 50 decimeter square. So how do we handle that? Convert this area to decimeter square. Convert this area to decimeter square. So how do you convert meter square to decimeter square? Meter square to decimeter square. Let's write the metric chart of length. Millimeter, millimeter, centimeter, decimeter, meter. So how do we convert meter to meter to decimeter? You can upwards, meaning multiply. You're converting a larger unit to a smaller unit. Meter is larger than decimeter. You're converting a larger unit to a smaller unit. So you need to multiply and multiply by 10, because multiply by 10. We have to convert meter square to decimeter square. Meter to decimeter is 1 meter is 10 decimeter. Okay, let's make it very simple. See, we are converting upwards, no, meter to decimeter. So we'll have to multiply. Multiply by 10. So meter to decimeter, we need to multiply by 10. Meter square to decimeter square, do that 2 times. So that is into 10 into 10. Into 10 into 10. So that part you can work it. So it will be 1320 into 10 into 10. 1320 meter square is 1320 into 10 into 10. Meter to decimeter into 10. Meter square to decimeter square, another into 10. Into 10 into 10. If it is meter cube to decimeter cube, into 10 into 10 into 10. Okay, so that is 1320 followed by 2 more zeros, decimeter square. Now we know we just have to multiply area with the rate. But what is the rate given? The rate is not given per decimeter square. It's given for 50 decimeter square. The rate is not given per decimeter square. It's given for 50 decimeter square. So you find for 1 decimeter square. See, it is 850 rupees for 50 decimeter square. So for 1 decimeter square, how much? 550. 1 minute. I think I was too fast. 1 minute. So see, it is given as rupees 850 for 50 decimeter square. See, we need to multiply the area with the rate per decimeter square. We need to find the cost. We need to multiply the area with the rate per decimeter square, right? Area into rate. Area is in decimeter square. So we need to multiply that with the rate per decimeter square. But here we have the rate for 50 decimeter square. So how much is it for 1 decimeter square? It will be 850 divided by 50. It's like 850 rupees is for 50 pencils. So for one pencil, how much? 850 by 50. If the cost is 850 for 50 pencils, how much is it for one pencil? 850 by 50. Similarly, it is 850 rupees for 50 decimeter square. For 1 decimeter square, how much? 850 by 50 will be the rate per decimeter square. You should multiply the area with the rate per decimeter square. So how much is it per decimeter square? 850 by 50. So that's what you can see below here. You can see below. The cost of canvas is equal to area into rate. You can see below. Cost of canvas is area into rate. Area is 132000 decimeter square into rate 850 by 50. Why? Because that is the rate per decimeter square. Don't multiply by 850. Rupees 850 divided by 50 will give you the rate per decimeter square. And then cancel them. Right? So first thing is the canvas is not used to make the floor of the tent. All right. So canvas is used to make only the CSA of the cylinder and the CSA of the cone. So it is 2 pi RH plus pi RL. Area we get in meter square because all the values are in meters. So we get the area in meter square. Convert that to decimeter square. Okay. And then the rate is not given per decimeter square. It is given for 50 decimeter square. So divide by 50 to get the rate for 1 decimeter square. Now multiply these two. Multiply the area in decimeter square with the rate per decimeter square to find the total cost. All right, next question. So a golf ball has a diameter equal to 4.1 centimeters. Its surface has 150 dimples. Okay, 150 dimples. A pimple is a bump. A dimple is a depression. Okay, a dimple is a depression. It's a depression. Some when we smile, we get dimples in our cheeks, right? Not all of us, but some of us, yeah, even I don't get it. Yeah, so dimples, okay, it's a depression. Its surface has 150 dimples, each of radius 2 millimeters. Calculate the total surface area which is exposed, assuming that the dimples are hemispherical. So the golf ball has 150 hemispherical depressions on its surface. The golf ball has 150 hemispherical depressions, not bumps, depressions on its surface. The golf ball is a sphere, the radius is given. For the hemispherical depressions, the radius is given. You need to find the area of the golf ball that is exposed to the surroundings. That means if you have to paint it, what is the total surface area? If you have to paint it up, what is the total area or what is the area of paint you would need to paint this? That's what you have to. Golf ball is a sphere, radius is diameter is given, so radius you have. Hemisphere you have radius, so you have all the values. You just have to construct that in words, that expression in words to find the area.
Sphere formula. தேடி கண்டுபிடிச்சு நான் எடுக்கிறேன். ஸ்பியரோட ஏரியா.
ஏரியா ஆஃப் ஸ்பியரா? 4
சரி விடுங்க, அது பார்த்து சொல்லுங்க.
4 pi r ஸ்பியரா?
தப்பு.
நான் சொல்றது கரெக்ட்.
Yeah, children, somebody's mic is enabled. Disable your mic. Pencil பக்கத்துல எழுதிக்கோங்க. Subtract, then you change the size. Yeah. Now, anyone online, tell me what is the expression in words to answer this question? What will you find? Online students, tell me the expression to be used to find the TSA exposed to the surroundings?
CSA of hemisphere
Ma'am.
plus
Yeah, Danya, one at a time. Yeah, Danya.
CSA of hemisphere plus area of sphere.
CSA of how many hemispheres?
150, ma'am.
150.
Okay, then. Okay, yeah, completed. Come again. CSA of 150 hemispheres. Okay, then.
And surface area of sphere.
Total TSA of a sphere.
Yes.
Okay, then Prajit. Somebody wanted to say no?
Ma'am, TSA of a sphere minus one TSA of 150 hemispheres.
Okay, so TSA of the sphere minus CSA of 150 hemispheres, right?
Yes, ma'am.
Okay, then anyone else with a different expression?
4 pi r square plus 150 pi r square.
Okay, 4 pi r square plus 150 pi r square. Huh?
Yes, ma'am.
How did you get that? 150 pi r square?
Actually, I substituted 3, ma'am, and I just solved 2 of those. I got 150 pi r square.
No, you must explain how it is 150 pi r square.
And
See,
because
like if I say,
because it's 115 hemispheres.
okay, 150, but from where did you get pi r square? And you're saying plus 150 pi r square. So you're adding the area of 150 circles. So how?
So I solved minus 150 pi r square plus 152 pi r square.
No, explanation I want. Okay, see, you may be right, but you'll have to explain how you got that expression. 4 pi r square, okay, because it is a sphere, so TSA is 4 pi r square. 150, okay, because 150 hemispherical depressions, but how 150 pi r square? Plus and why is it plus and why not minus? So you arrived with that with some earlier steps, right? I want you to explain them. Okay, anyone else? Here, class. Minus 150? Okay, so TSA minus 150 hemispheres. Into okay, same. Okay. Okay. All right. So Sashank was right. See, when it is volume, you can do that subtracting, when it's volume. When it's area, you will have to add whatever is there and take away what is not there. You must first have that something you must first have that whole thing. Okay, that maximum area you should have first. And from that you should subtract what is not there and add whatever is there. So the golf ball. So first take the TSA of the golf ball, 4 pi r square. Now ask yourself, do you find the entire surface area? Is the entire surface area of the ball there? Meaning, is the material on the surface area completely intact? No. Because of the hemispherical depressions, the circular mouths, 150 circular mouths are not there. When you find 4 pi r square, you're finding the surface area of the golf ball as if it is smooth all over. As if there is material all over. When you find 4 pi r square, TSA of the golf ball, 4 pi r square, you're finding the area as if it is smooth all over. But no, there are 150 hemispherical depressions. And because of the hemispherical depressions, 150 circles are missing on the top. The area equal to the area of 150 circles are missing on the top. The area equal to the area of 150 circles. Why are we saying circles? Because the hemispheres have a circular mouth. So the area equal to 150 circles are missing. But you have found that area in 4 pi r square. 4 pi r square includes the whole area. But of that, the area of 150 circles are missing. It's not there. It's gone away because of the hemispherical depression. So 4 pi r square minus 150 pi r square. Now the the depressions have created more area. The hemispherical depressions have created more area. So 4 pi r square minus 150 pi r square. That is minus the area of 150 circles plus what is there. Take away what is not there and add what is there, what has been created. So plus 150 into 2 pi r square, the CSA of a hemisphere. When you find, see, this is the expression. It's 4 pi r square minus 150 pi r square plus 150 into 2 pi r square. 4 pi r square is the total surface area of the spherical golf ball, assuming that it's smooth all over. Okay. But because of the hemispherical depressions, 150 circles are missing on the top. You understand how it looks like, no? See, I don't know if this drawing is good, but then see like this. Because it is 3D, I can just manage to do this. You can see how I've represented that. Can you see it's like this? Can you see that? So on the top, it's not there. The circles are not there. It's not a bangle. That's the golf ball. So the circles on the top, 150 circles are not there. But you found the area of 150 circles in 4 pi r square. 4 pi r square includes the full area. That means you've included the area of the circles, but they are not there. So take away the areas of the area of 150 circles. Take away from 4 pi r square, take away the area of 150 circles, minus 150 pi r square. Now we have the hemispherical depressions, right? Whose area is 2 pi r square. So add that because you have to paint there. No, if you have to paint, you'll have to put a brush there also. The circles, they are not there. So you'll try to brush, but there is no circle. That's why we took off that area. But the hemispherical depressions are created. So if you have to paint, you'll have to paint it there also. The depression you have to paint. That means you should add. If you can paint it, you have to add. If you want to paint, but that area is missing, take it away. So 4 pi r square minus 150 pi r square plus add CSA of the hemispheres plus 150 into 2 pi r square. 2 pi r square is the CSA of the hemisphere. Pi r square is the area of the circular mouth. Is that fine, children? So 4 pi r square minus the area of 150 circles, 150 into pi r square, plus 150 into CSA of the hemisphere, 2 pi r square. So you can simplify that. This will be minus 150 pi r square plus 300 pi r square plus 300 pi r square. So it is 4 pi. This you please use a capital R. I'm sorry. This you can use a capital R. 4 pi r square minus plus 150 pi r square. Because these have the same radius. This r and this r both are the same. So 4 pi r squared plus 150 pi r squared. This r is r of the sphere, the golf ball. This r is of the hemisphere and the circle, which is the same. So you can simplify. Please work this. I don't want to show the working, so you just have a look how it's worked. Right? Please work in millimeter. The radius of the depression is in millimeter. The golf ball is in centimeter. Please convert centimeter to millimeter. So it is TSA of the spherical ball minus area of 150 circles plus area of 150 hemispherical depressions. Got that? Yeah, because I don't want you to take the calculations from the screen. Have a look. Okay, that's it. Yeah, please work. It's the speed, it should really not take, it should not take us. Why is it to take us? Yeah, what's the final answer? Online students? What's it you got, Ritika? Final answer, online students? All right. Here, anyone wants to share your answer? 7-1. So simple it is. So 4 pi capital R square plus 150 pi small r square. Substitute 20.5 and 2 and then yeah. See, when you have pi in more than one place, don't use the value of pi everywhere. When you have pi in more than one place, don't use the value of pi. Once for all of you. So I got 2281 pi. Area is 2281 pi. And then in pi, 22/7. Yeah, it doesn't divide exactly. So approximately 71.68 centimeter square. Millimeter square, it is 7168.817. Millimeter to centimeter, we need to divide by 10. Millimeter square to centimeter square, divide by 100. You can leave the answer in millimeter square. Yes, Sashank, it's not tallying our answers. 71.66. So you've used the value of pi everywhere, is it? Yeah. Okay. So that what happens, so you have an approximate value, another approximate value. There's some is another approximate value. That's why the difference. You understand what I'm saying? So when you substitute what you should do, you should have them as fractions itself. By 7 by 7. Then LCM is by 7. Yeah, then you should get the same answer. Then you must get the same answer. What's the final fraction you have? Tell me, I'll use a calculator. 50,000? Yeah. 7168.857. Children online, you're quiet. If you have a question, please ask me. When you have pi in more than one place, don't use the value of pi. Yeah. You have one question, huh? Oh, yeah, sure. Fan only. I think. Yeah, so if you have the value of pi in more than one place, don't use the value of pi. Once for all, see 1681 pi, 600 pi. So it is 2281 pi. Any questions, children? No? Madhumita? Boys? Arjun? All right. Sorry? இல்ல இங்க எல்லாம் இருக்கு. சரி கேளுங்க என்னன்னு. ஐடியால ஏதாவது ப்ராப்ளம் இருக்கா? இல்ல. ஏன்னா இது வேற ஒன்னும் டிஃபரெண்டா ஒர்க் பண்ணவே முடியாதுன்னு தான் நான் பாக்குறேன். So how you have gone wrong? Only thing you can do is pi ஓட வேல்யூ அங்கங்க 22/7 போட்டுக்கலாம் அவ்வளவுதான். There's no other way. All right, next one. Yes, Dileepan? Nothing, okay. Got the second one? Or you can try as homework. I think last class we did that. Right triangle revolved about the hypotenuse. So you can work that as homework. Fourth one, we did it in the last class. After 3, please try 5. After 3, try 5. Yeah. So what's the volume? Volume? $754.28. Just a minute, I want to. Yeah, I'm so sorry. Just 754. Yeah, ரெண்டு பேருக்கும் ஒண்ணா எனக்கு மட்டும் டிஃபரெண்டா இருக்கு. Oh, volume. Yeah. 754.28. Correct. Yes. Area still to find. Okay. So to find the volume of the remaining solid, what was the original solid? Cylinder. From that, what is removed? Cone. So volume of cylinder minus volume of cone. Volume works like that. Volume works like that. Volume is, what was the whole thing first? Cylinder. What is removed? Cone. So the volume of the remaining solid is volume of the cylinder minus the volume of the cone. Should be careful with the area. Finding area, you should be careful. Area is not TSA of the cylinder minus TSA of cone. It's not like that. Areas, and the remaining solid எங்கெல்லாம் surfaces இருக்கோ அந்த surfacesக்குலாம் என்ன ஏரியாக்கு என்ன formula அந்த expressions எல்லாம் எழுதணும். அந்த resultant solid, remaining solidல எங்கெல்லாம் surfaces இருக்கு, where all you can paint, அந்த surfacesக்கு அந்த surfaces ஓட ஏரியா கண்டுபிடிக்க என்ன expressions formula அதெல்லாம் எழுதணும். CSA is not CSA of that minus CSA of this. It's not like that. Volume works like that, not area. Yeah. What surface area? Try the next one. Try the next one. Not this one. Yeah. Yeah, just 2 minutes. Yeah. Yeah, I want to know the answer from you first. Surface area. Surface area. Yeah, see you, darling. Yeah. 710 point. Perfect. 16. Yeah. So here you go. Answer for the third one. Answer for the third one, children. You can see the volume here. See the volume here. Volume is here. Hey, am I able to annotate? How come? So volume of the remaining solid is volume of the cylinder minus the volume of the cone. Pi r square h minus 1/3 pi r square h. Since both the cylinder and the cone have the same radius and same height, you can use the same letters r and h, and so you can subtract 1 pi r square h minus 1/3 pi r square h is 2/3 pi r square h. Since the cylinder and the cone have the same radius and height, so pi r square h minus 1/3 pi r square h is 2/3 pi r square h. 1 minus 1/3 is 2/3. 1 minus 1/3 is 2/3 pi r square h, and then substitute the values, and it's 754.28 for volume. Area of the remaining solid. How many of you did not get 710? You didn't get 710. 7? Oh, no, but this expression you wrote correctly. CSA of cylinder. Girls here? Okay. So when you remove a cone from a cylinder, a solid cylinder, a cylinder has 2 circular ends. With the cone, 1 circular end is gone. A cylinder has 2 circular ends. When a cone of the same radius and height is removed from the cylinder, one circular face goes away with the cone. So the other circular face of the cylinder is intact. Along with the, when you remove the cone, one face of the cylinder, one circular face of the cylinder is gone with the cone. What about the other circular face of the cylinder? That is there in the cylinder, correct? Or that is there in the remaining solid. So the area, surface area of the remaining solid is, visualize CSA of the cylinder plus the CSA of the circle. And then inside you can see the CSA of the cone. See, where all will you paint? Imagine a solid cylinder, and when you remove a cone, say it's a wooden cylinder. So from this wooden solid cylinder, you remove a cone of the same radius and same height. So now imagine the resultant solid, how it would look like. Now, if you have to paint this, where all can you paint? You can paint the CSA of the cylinder, then the base of the cylinder, that circle. Then if you look inside, there's a depression, there is a conical depression. If you can now look inside, because the top circle is gone with the cone. Now you can look inside the cylinder. And when you look inside the cylinder, you see a conical cavity, and that can be painted. If you don't paint, that will be brown, because it's out, it will be brown. So where all will you paint? CSA of the cylinder, the base circle of the cylinder, and if you look into the cylinder from the other end, you can see a conical cavity. You should paint that also. 2 pi RH plus pi R square plus inside pi RL. These are the three surfaces that are available to be painted in the resultant solid or in the remaining solid. CSA of the cylinder, area of the base, and the CSA of the cone. So nowhere I've substituted the value of pi, 2 pi RH, pi R square, pi RL, everything in terms of pi. I add everything and I get 255.96 pi. Then once for all, the value of pi 22/7, and I get 710.16. I think you can adopt the same way of calculating. Or you can take pi common. Instead of taking pi common, I think this will be easier. Or you can take out pi R common. When you take out common, be careful while working. Yeah, now any questions regarding the remaining surface, children? No? All right. Yeah. Yeah, you can tell me. 712. What is this one? Okay, tell me the area to be polished. No, I'm meaning my answer is different here. So let me just check the area. What's the area we've got? Oh, you didn't directly you found the cost, is it? Okay, okay. Oh. No, it's different. It's more than 800. It's between 800 and 900. Yeah. So what's the radius of the cylinder, online students? Radius of the cylinder for the first one?
18, 18 centimeters.
18. Okay. And the height of the cylinder? Height of the cylinder?
One not 8 centimeter.
Rakshita, not the, what is that called? What's that object called here? What's the object called? A solid, okay. Rakshita, not the height of the solid, the height of the cylinder. What's the height of the cylinder? Not the height of the solid. The solid's height is made up of the height of the two hemispheres and the height of the cylinder.
Ma'am, is it 72?
Yeah. 72. Let's have a look at that. So a solid is composed of a cylinder with hemispherical ends. Cylinder with hemispherical ends. With hemispherical ends. Now the length of the solid is 108 centimeters. The length of the solid. The length of the solid, is it given height here? Okay. Okay, so the length of the solid is 108 centimeters. What is the length of the solid made up of? It's made up of the length of the hemisphere plus the length of the cylinder plus the length of the hemisphere. I'm saying length, which is the height. If it's vertical, it's height. If it's horizontal, we say length. We say length when it's horizontal, height when it's vertical. There are two things here, solid and cylinder. 108 centimeters is the length of the solid. But we want the length of the cylinder. The length of the cylinder, this one alone. So we know that the height of the hemisphere is equal to its radius. The height of the hemisphere is equal to its radius. Radius is 18. So height is 18 here. Here also the height is 18. So 108 minus 18 plus 18, 36. Subtract 18 from both the ends. Length of the solid is 108. Length of the cylinder is not 108. 108 minus 18 from both the sides will be the height of the cylinder. Yeah. Can have a look at the answer. Yeah, correct. But it's precisely 855.36. That's not an approximation. It's precisely that. So you can see here, this is HS, hemisphere. Hemisphere radius is 18. For cylinder, radius 18, height is 72. Area to be polished is equal to CSA of the cylinder plus the CSA of two hemispheres. Only CSA is exposed. Only CSA is exposed. So CSA of cylinder 2 pi RH, two hemispheres. So 2 into 2 pi r square, 4 pi r square. 2 pi RH, 4 pi r square. So children, see, we can use the same R. You can use same R, meaning small letter R for both because the radius is the same. R for the cylinder, R for the hemisphere, both are the same. So you don't have to use capital R and small r or R1, R2. Only when the radius is different in value, then we say R1, R2. So here it's the same. So you can take out 2 pi r common. See, be careful. Only when the values of R is the same, you can use the same R everywhere. So on working, substituting and working, I get 855, sorry, 85,536 by 7 centimeters square. Don't convert that to a decimal because that's not the final answer. We have to find the cost of polishing. So that is given to be cost of polishing is 7 paise per square for 1 square centimeter. So for 1 centimeter square, 7 paise for 1 centimeter square. So it's given per unit only. It's 7 paise for 1 centimeter square. So you find the area in centimeter square and multiply by 7 paise. So we'll get the answer in paise. Divide by 100 to convert that to rupees. Or you can multiply by 7 by 100. 7 by 100 meaning rupees 7 by 100. The rate is given per centimeter square. Seven by 100 is to convert paise to rupees. 7 paise, convert that to rupees. 7 by 100. So the answer is in rupees. You could make out your mistake. That where? Oh, other one. Okay. Madhumita, got it? Oh yeah, you didn't get it. என்ன சொன்ன நீ? மறந்துட்டேன். You said something. No, can you see it? It's this simple. இங்க எங்கேயுமே எனக்கு பண்ணக்கூடாது அது. அதை எதுக்கு பண்ணணும்? எக்ஸாக்ட்லி டிவிசிபிள்னா தான் கேன்சல் பண்ணணும். இல்ல 0.5 வருது இல்ல 0.1 0.2 அப்படி டெர்மினேட்டிங் டெசிமலா வந்தா கேன்சல் பண்ணலாம். If it's not terminating, then you should not cancel. And later part of the question கொடுத்திருக்கல rate வந்து 7 பைசேன்னு. So அந்த 7 இந்த 7 கேன்சல் ஆயிடுமே. அதனால தான் டிவைட் பண்ணல. If the rate is 14 paise, 21 paise, 35 paise, don't divide. Divide panalo, you're not going to get a terminating decimal. So just leave it as a fraction. Okay, see, I'll answer this question also. Supposing you found the decimal value. Now, 85,536 by 7. You found the decimal value. Okay. And then you work the cost. There you should realize that the decimal value is only an approximation because it's not a terminating decimal. It's a non-terminating decimal. It's an approximate value, right? Now, even if you found the decimal value, don't use that for further calculation. Use the fraction because only with that you will get the exact answer. Because we used to know whenever we see a fraction, நம்ம divide பண்ணி decimal போடுறது, we are used to that. It's okay. So you spend that 3 minutes extra to find the decimal value. Fine, you have it. Then later when you proceed to find the cost, Anga, you should realize that 7 paise it is per centimeter square. Ingu on the earlier fraction, 7. Let me take the fraction itself to get the exact value. You should realize that. So even if you found the decimal value, don't use it for further calculation. Use the fraction for further calculation to get the exact value. So the expression is 2 pi RH plus 4 pi R square. I've taken out 2 pi R common because R for the cylinder and R for the hemisphere is the same. So you can take out 2 pi R common. So you get H plus 2R. Substitute the values. Fraction I've kept it as it is and multiply that with 7 by 100. That's it. Online children, please tell me if you have any questions with this. With the fifth answer. Any doubts, any clarifications for the fifth one?
No, ma'am.
No.
Thank you. Yeah, 6. Sixth one. So Arjun, what is the radius of the cone? Radius of the hemisphere? Height of the, 1 second, height of the toy? Height of the cone? Height of the hemisphere? Very good. So how do you find the volume of the toy? Two by three? Two, three. 2 by 3 pi r cubed. You can remember like this. What's the formula to find the volume of a cylinder? Cylinder. Pi r square h. What is this? Pi r square h, right? R square into h. So here also it is 2 by 3 pi r square into h, which is r only. H is equal to r, right? H is equal to r here. So it's 2 by 3 pi r square. Just remember like pi r square h. But what is h? R itself. So 2 by 3 pi r square into r. That's why it's r cubed. 2 by 3 pi, not r square. R square h. H is r. So 2 by 3 pi r cubed. That's why for the sphere also it is 4 by 3 pi r cubed. Yeah. Yeah, you're in a deep thought. In the story writing, இல்லையே ஃபார்முலா சப்ஸ்டிட் பண்ணி கால்குலேட்ல பண்ணோம். என்ன யோசிச்சுட்டே இருக்க? No, what are you thinking? Read what's in your book. Read what's in your book. கேளுங்க, don't waste time. என்ன தெரியல? Hemisphere 2 by 3 pi r cubed. எவ்வளவு எக்ஸாம் எழுதிருக்கீங்க ஸ்கூல்ல? Okay, next. Cylinder cone. Raja. Cone. Pi. இல்லம்மா. R square h. See. 1 by 3 pi r square h. 2 by 3 pi r cubed. All right, good. Yeah. What's the answer? Yes, Sashank? 260. இல்ல நீ ஏதோ addition error பண்ணிருக்கு. Correct தான், but what's your answer? Yeah, it's not that. Yeah, that's what I said. ஏதோ addition error. Division பண்ணி. Okay. Simply. Okay, 266.112. இல்ல 266. I'm not getting the final answers from the others. It's been only Navya or Sashank in the class here. Others are working, but why not able to come to the answer faster than the others? Where are you stuck? Online students? Rakshita? Working or got the answer?
Just a minute, ma'am. Last.
Okay, Krish Ritik, Prajit, Krishmi, Danya, and Florentina got the final answer?
I got 266.112.
Yeah, 266.112. Yeah, what is the read what you've written prior to that step?
And I wrote 1 by 3 into 22 by 7 into 4.2 into 4.2 into 2 into 4.2 plus 6. By solving, I got 22 into 0.84 into 8.4 plus 6. And by solving that, I got 266.112.
Okay. Good. Navya, found the mistake? No, okay. Oh, yeah, do that. Yeah. Diliban, any help? Yeah. Got that? Very good. Because the calculations are not tedious. They are not tedious. R is the same. Hemisphere, cone, R is the same. So I've taken out 1 by 3 pi R square. 1 by 3 into 2 is 2 by 3. 1 by 3 into 2 is 2 by 3. So 1 by 3 common ulla 2. 1 by 3 1. So here 2 by 3 pi r cubed is for the hemisphere. This is for the cone 1 by 3 pi r square h. So 1 by 3 pi r square is common. 1 by 3 pi r square is common. So 1 by 3 into 2 is 2 by 3. And r square into r is r cubed. And 1 by 3 pi r square is out here. So h alone inside. So I can see that, this one is what? 14.4. Now this is divisible by 3 because 4 plus 4, 8, 8 plus 1, 9. Test of divisibility. This is divisible by 3. So this 3 and this one will get cancelled. And then 4.2 is divisible by 7. So Abhinay, the exact answer, 266.112, precise exactly. This 3 and this one, 14.4, you can cancel. 14.4 is exactly divisible by 3. 4 plus 4, 8 plus 1, 9. And we have this 4.2, which is divisible by 7. 0.6 times. So you must get exactly 266.112. After this step, I have used the calculator, children. That's why I've written the final answer. You will have steps after this. I have used the calculator. So after this, I've written the final answer. You will have 1 or 2 steps in the middle. So read the question, draw the figure, rough figure, then write out the solids you see, cone and hemisphere. Write their parameters, radius, height, and here radius. And then that expression to find volume. Write the formula, common factor. So these are the steps normally in most questions where it's a combination of solids. All right, next one. Question number 7. The question continues on the next slide. You have to write down till here. Find the area of the surface. Find the area of the surface and the volume of the building. Find the area of the surface and the volume of the building. Find the area of the surface and the volume of the building. In yeah. Vertical angle is a right angle. Huh. The cylinder is surmounted, so the ceiling is not flat. The ceiling is conical. The building is cylindrical. It's mounted by a cone, not mounted on. It's mounted by a or surmounted by a cone. Yes, correct. What the question? Previous page. Yeah. Yeah. That's right. அதுதான். Think and tell me if that is missing or if it can be found. Should we? Application, yeah, trigonometry with inga vandu because it's 90 degrees trigonometry illama kodum pannalam. Correct, he's right. So when the vertical angle is given, see, we use trigonometry or trigonometric ratios to find the missing angle or missing sides in a right triangle, right? When less information is given, you can use trigonometric ratios to find the missing sides, right? He's right. He's right. But inga avlo effort kuda vendam. Pannalam. Angle of inclination? Inclination of what? Or the radius and the slant height of the cone, that inclination is given. But you can find. Okay. So, good. Nice questions. So, children, it is cylindrical. It's cylindrical. The building is cylindrical, surmounted by a cone. This vertical angle is 90 degrees. Now, this is the altitude of the cone. This is the radius. This is 90. So, this will be 45 here and 45 here. So, now this is a right isosceles triangle. This one is a right isosceles triangle. This is 45. This is 90. So, this is also 45. So, this one is a right isosceles triangle. The hypotenuse is the longest side in any right triangle. So that cannot be equal to any other side, which means the legs are equal. So whatever is the radius of the cone or the cylinder. Okay, so whatever is the radius of the cone is the height of the cone. The vertical angle, this full thing is 90. The vertical angle meaning this angle is 90. So it will be 45 on either sides. Okay. So now this triangle is already a right triangle and this angle is 45. So this also will be 45. So it's a right isosceles triangle because 45, 45. Right isosceles triangle, meaning two sides are equal now. Hypotenuse leave because that's the longest side. So the remaining two sides are equal. That means the radius and the height, they're equal. So whatever is the radius of the cone is the height of the cone also. That's all. The interior of a building is in the form of a cylinder of diameter this much and height surmounted by a cone of vertical angle. Find the yes. Find the area of the surface and the volume of the building. Surface meaning the surface. Yes. Actually, it's not very clear here. When it is surface, it is not really clear. Let me just, such things will not be given, children, so don't worry about it. So let's just say, find the curved surface area of the building. Find the area of the surface, find the curved surface area. I'll include that word. Find the curved surface area. So find only the CSA. This one is deceiving. It's difficult to, like judge what it means. So it will be clear. The questions will be clear. So don't worry about that. Find only CSA here. Because as the word surface, we have in total surface area and curved surface area. Surface comes in both. This word surface comes in total surface area and curved surface area. So it's deceiving here. Let's do only CSA. Want the question? Navya? Online students, use the emoji, raise your hand. Very good. Prajit, Florentina, Danya, Krishni, Rakshita. You're there, Krish? Are you there, Krish? All right, so let's discuss the values for radius and height.
My phone is stuck, ma'am.
Okay, fine. Okay, Krish. Yeah, children. So this building has a cylindrical base surmounted by a cone. Yeah. So radius of the cone and cylinder. What's the value of the radius of the cone and cylinder? Radius. 2. Okay, you said 2 or 4. I heard 4. Sorry. 2.15. Fine. 2.15 meters. The radius of the cylinder, radius of the cone, 2.15 meters. Okay, now height of the cone. Height of the cone 2.15 because radius is equal to the height. So height of the cone 2.15. Height of the cylinder. அதுதான் டவுட்ல நீங்க டிஸ்கஸ் பண்ணிருந்தீங்கன்னு நினைக்கிறேன். சப்ட்ராக்ட் பண்ணுமா பண்ணக்கூடாதான்னு. இல்ல, okay, what's the height of the cylinder? 3.8 or 3.8 minus 2.15. How? Huh? Correct. Yeah, because it's given is in the form of a cylinder of diameter and height. Is in the form of a cylinder of diameter and height. So the diameter and height is of the cylinder. Is in the form of a cylinder of diameter and height. Of diameter something and height something. So diameter and height are of the cylinder. So cylinder's height only is 3.8. It's not the height of the building. The height of the building is not 3.8. 3.8 is the height of the cylinder. That's how it's given there. So what will be the height of the building? 3.8 height of the cylinder. That's not needed for meaning anywhere, but what's the height of the building? Height of the cylinder plus the height of the cone. Height of the cylinder 3.8 plus the height of the cone 2.15. Okay. For volume. Volume. Sorry. Yeah, tell me what you've got. It's between 60 and 70. Okay, a formula to find the volume of cylinder. Pi r square h. Then cone 1/3 pi r square. H1 you can say. Have you taken out common? Oh, you took same h for both? Ah, that's why. When they have different values, you must use. Ah. H for the cylinder is different from cone. That's why you should differentiate H1 or H1, H2 or small h, capital H. They have different values. CSU, which one you want to say? Surface area, yeah. 29 simplify பண்ணுங்க. 20? 29.0293 into 1 plus 2. Oh, into 1 plus √3 you said. √2. No, I can only show you the answer. Because yeah. Well, okay, so here I think I've used trigonometry to find, but you can do what we have done now. I've used trigonometry to find the height. So you get the same thing, 2.15. Tan 45 is equal to opposite by adjacent. You can use trigonometry. Okay, so that's how I found. And yeah, I've also found the slant height. You have to find the slant height, right? Because the area, for area, you need slant height. So I found the slant height not using Pythagoras theorem, but by using trigonometry. I found the slant height using trigonometry and not Pythagoras theorem. So 2.15 root 2. For 71.83 is surface area and 65.56 is volume. Okay, I'll be sharing all these images. So we found the height of the cone using isosceles triangle property, right? Isosceles triangle property, right? So here you can see I've used trigonometry, so that's okay. You understand that. And then slant height also using trigonometry and not that relation L is equal to root of h square plus r square. Anyways, either ways, you know, you'll get the same answer. So answer will not change, but you can use trigonometry because we know one acute angle in the right triangle. And then surface area. Yeah, so you might be like, oh, sometimes she takes out 2 pi common, sometimes she doesn't take off. Maybe at that time I wanted children to, I was just trying to project both. I don't remember with what intention I worked it at this, but then you can do it either ways. You can even take out, you know, what pi r common. You can even take out pi r common and work this, correct? Pi is common, r is also common because r is the same for the cylinder and the cone. You can take out pi r common and work it. You will get exactly the same thing. Okay, fine, it's time, children. All right, children, so that's it for today's session. I'll share all these answers. Plus, please complete this by the next class, the remaining questions of today's class work. I have 15 questions here, of which we have finished 9. 8 we have finished. 7 we have finished. 15 I have. Okay, try to finish. No, that will not be uniform. I'll share. Will you have time to do homework? No, yeah, because if some of you do it and others don't do it, then it'll be a confusion. Fine, we'll continue the next class today. Yeah, online students, you may leave the meeting. Thank you. Good night. Thank you, children. Thank you. Good night.